For decades, the Soviet Union created experimental trucks that broke all conventions, from electric giants to plastic dumpers and turbine engines. Why did so many end up forgotten? Today we'll uncover these mechanical titans, their bold innovations, and the failures that marked a unique era in the history of Soviet transportation. Stay until the end, because this story will surprise you. MAZ 525, the 25-ton Colossus. It all began with a true giant, the MAZ 525 truck, in Russian MAZ 525, a beast with a payload capacity of 25 tons, something extraordinary for its time. This model marked the beginning of a new era of colossal dump trucks, designed specifically for hauling loose materials in open-pit mines. This engineering mastodon was used until the 1970s, but few know that there was an even more advanced and ambitious version. The MAZ 525 TTU, MAZ 525 TTU, a fully electric variant that operated like a trolleybus with a cargo platform. Technically, it was a cargo trolleybus, a rare breed known as a trolley truck. MAZ 525 TTU, the forgotten electric giant. The design was the result of a collaboration between the Mining Institute of the USSR Academy of Sciences, the MAZ plant, and the Kharkov trolleybus depot. Its purpose was clear: to turn the Belarusian monster into a more economical and efficient vehicle. The model was introduced in 1954. It drew power from overhead electric cables just like urban trolleybuses. Two metal poles mounted on the roof made contact with the wires, transmitting electricity to its two coaxially installed electric motors connected by a drive shaft. Why two motors? Because at that time the Soviet industry was not yet capable of producing a single electric motor powerful enough to move such a behemoth on its own. This solution, though complex, gave the vehicle 76% higher performance than a conventional dumper, while also reducing the cost per ton transported by 39%. This electric Titan used DK202 type motors, which together delivered 172 kilowatts of power, about 230 horsepower. Its control system consisted of a single controller and 4 contact panels. By comparison, the diesel version of the MAZ consumed about 135 liters of fuel per 100 kilometers. The trolley truck, meanwhile, could reach a maximum speed of 30 kilometers per hour on flat routes, and all its hydraulic systems, including power steering and the dumping mechanism, were also powered electrically. Despite its promising performance, the electric model did not succeed. While its theoretical usefulness was recognized, the conditions needed for its operation were nearly impossible to meet in practice. Its poor adaptability to real terrains and dependence on fixed infrastructure limited its application. The experiment lasted roughly a year, after which the truck was left as a living museum piece, unique in its kind. However, the idea of the trolley truck was not completely abandoned. Some years later, the Soviet Automotive Research Institute revisited the concept, applying it to Belaz dump trucks in the late 1950s and early 1960s. ZIL MMZ 555, the plastic dump truck of the future. The next unusual experiment emerged from the Soviet drive to innovate with new materials. During the transition between the 1950s and 1960s, many factories in the country were researching how to apply plastics and synthetic composites to vehicle production. This is how the ZIL MMZ 555, ZIL MMZ 555 came to life, a dump truck with a fiberglass body. In some sources, it is also referred to as ZIL MMZ 555P, where the P stands for plastic in Russian. But why use fiberglass to build a dumper? The answer was both economic and practical. The standard ZIL 555 model was not suitable for transporting agricultural products, something that irritated automotive sector officials who demanded multi-purpose trucks. On top of that, the main issue with agricultural dumpers was the corrosion of their bodies when carrying unpackaged mineral fertilizers. These chemicals reacted with the metal and caused rapid deterioration. Fiberglass, on the other hand, provided chemical resistance and greater durability. It also aimed to reduce the complexity of manufacturing. Building a metal bed required extensive welding. Using fiberglass simplified the process and reduced the truck's weight. With this method, payload capacity could be increased by about 200 kilograms. It may not sound like much, but in logistics, every kilo matters. The design of the fiberglass dumper. This innovative truck was built on a ZIL 301 type chassis with a wheelbase of 1,300 millimeters. Its body was a single molded piece, spoon-shaped with no rear door. Only the upper visor was a separate plastic part. The dumper's volume was 2.75 cubic meters. The floor thickness, especially at the center, the area most exposed to impacts, was 15 millimeters, while the side walls were between 10 and 12 millimeters thick. The structure was made of polyester resin reinforced with fiberglass fabric. This plastic zeal was produced in a single unit. The plan was to manufacture up to 10,000 units annually if tests proved successful. And indeed, the prototype passed resistance trials. Even damaged sections could be easily repaired with fiberglass patches without the need for special equipment. But the dream of the plastic truck died quickly. Technological difficulties prevented mass production. Although the idea was to reduce manufacturing workload, in practice it turned out to be the opposite. It required even more labor than building a metal bed. Moreover, at that time the USSR had no industry capable of automating such a process. Engines of the future. The gas turbine era. While diesel trucks dominated the highways in the West, in the Soviet Union engineers dreamed of something more futuristic: gas turbine engines. By the 1950s, these power plants had already proven their might in jet aviation. Then came the inevitable question: what if we put them in cargo trucks? Initially, the Military Automotive Research Institute took interest in the concept. But soon designers at the gas factory joined in, daring to create their own experimental engines. The project to assemble trucks with these revolutionary machines was handed to Department SB2, which began working on specially adapted chassis for the task. CRAS E260, the first gas turbine experiment. The first creature born from this technological fever was the experimental CRAS E260 truck, CRAS E260, assembled in 1974. This vehicle carried a two-stage gas turbine engine, designated the GAZ-99D. Among its main advantages were reduced emissions, a weight half that of a conventional diesel engine such as the well-known YAMS E238, and energy efficiency that was 20% higher. But not everything was rosy. The engine reached a staggering 33,000 revolutions per minute under normal operation. Such a figure was unsustainable for any standard gearbox. To adapt it, an extreme solution was used: a special reducer that brought the revolutions down to a more manageable 3,000. This transmission system, along with the clutch and gearbox, had to be imported from Hungary, since nothing in the USSR was compatible with such rotary power. The design of the CRAS E260 required a complete redesign of the hood, elongated significantly to house the massive engine. The result was an imposing silhouette, almost like science fiction, but testing went poorly. The complex transmission could not withstand the demands of the engine and failed prematurely. CRAS 2 E260E, the second attempt. 2 years later, in an effort to correct mistakes and improve the proposal, a second prototype was born, the CRAS 2 E260E, CRAS 2E 260E. This new version integrated an updated engine, the GAZ-99DM, with 360 horsepower. It was more compact, allowing it to be installed in a cab with a standard hood without extensions. This new power unit was also lighter and more efficient. The truck had a gross weight close to 22 tons and a payload capacity of up to 10 tons. Although promising on paper, the field results were disappointing. The same Achilles heel of the previous model reappeared. The gearbox could not withstand the strain of transmitting the brutal power of the gas turbine engine. The project, known internally as 2260E, was cancelled in the early 1980s. Why bet on gas turbines? Despite these failures, the Soviet insistence on this type of engine was not arbitrary. Gas turbines offered a series of advantages that were highly attractive: fuel versatility. They could run on virtually any liquid fuel, from kerosene to heavy oils, cold weather starting, much easier to ignite in winter than traditional diesel engines. Low emissions, exhaust gases were much cleaner. Reduced consumption in specific conditions. At maximum load and constant speed, consumption was lower than that of a conventional engine. But these advantages had a dangerous flip side. At low speeds, during starts and stops, fuel consumption skyrocketed. In addition, transmission components were not up to the task of handling the power and rotational speed of turbines. And this was a problem that not even the vast Soviet industrial machine could solve. Mining trolleybuses and science fiction trucks. Curiously, the Soviets were not completely discouraged. The idea of using electric networks to move heavy vehicles remained alive. After the failed experiments with the MAZ 525 TTU, attention shifted toward Belaz trucks, with new trolley truck designs emerging in the following years. The challenge, as always, was technical and logistical, creating a cable charging system in mines with distances. Curves and dust was a monumental feat, but that characteristic Soviet stubbornness kept pushing the limits of the possible. In many ways, these trucks looked like they came out of a science fiction novel. Enormous, electric, silent, and with engines humming like airplanes. But the technology and the industry weren't ready, and so, one by one, these experiments ended up shelved in hangars, archives, and the memories of engineers who had once dreamed of the future. Beyond metal, experimental trucks with plastic bodies and unusual solutions. The drive to innovate led Soviet engineers to think beyond steel. In times when metal was scarce or not durable enough, attention turned to composite materials. The use of fiberglass reinforced plastic began to emerge as a viable option for truck bodies, especially in agricultural applications where corrosion was a constant, silent enemy. One of the most emblematic examples of this exploration was the ZEAL MMZ 555P, ZEAL MMZ 555P, a fiberglass-bodied dump truck intended for hauling mineral fertilizers. We already saw it in the previous part, but its story represents a constant theme in the Soviet industry, the continuous attempt to turn material challenges into technological innovation. The war against corrosion, how reinforced plastic promised to save the cargo. The goal was clear: to solve the problem of the rapid corrosion suffered by metal dump beds when transporting unpackaged fertilizers. The direct contact between mineral salts and steel caused severe oxidation in a very short time, reducing the vehicle's lifespan and generating enormous maintenance costs. Fiberglass, on the other hand, offered chemical resistance, lightness, and ease of molding. The bed built for the ZEAL MMZ 555P was not only lighter but also monolithic, manufactured in a single piece without joints that could weaken the structure. This allowed, for example, an increase of about 200 kilograms in payload capacity. Even though the prototype passed tests with good results, mass production failed. The technology to manufacture such parts with precision and speed was not yet developed enough, and the process required a lot of specialized manual labor. In an industrial environment that sought efficiency and volume, that was an insurmountable obstacle. From glass to gas, the USSR and its love affair with experimentation. Soviet creativity didn't stop there. While the rest of the world leaned toward more conservative solutions, the USSR kept betting on the unexpected. Gas turbine engines, trolley trucks, and even hybrid electric mining vehicles were part of a constant race to break with convention, to create machines that had no equivalent in the capitalist world. Between the late 1950s and early 1960s, many of these ideas were driven not only by the urge to innovate, but also by political and strategic reasons. Proving that communism could lead in automotive technology was as important as building tanks or satellites. Parallel projects, trucks that almost existed. During these years, vehicles were designed that never even reached the prototype stage, but whose plans and sketches still survive in archives. Some examples. A dump truck with 3 powered axles and hydropneumatic suspension designed to adapt to terrain without losing stability. A 6-wheeled electric platform for military cargo transport powered by a nickel-iron battery with a 40 kilowatt-hour capacity. A truck project with active rear steering to allow maneuvers in very tight spaces intended for densely populated industrial cities. These ideas, even though they never materialized, reveal the bold mindset that reigned in Soviet automotive development centers. Any concept, no matter how impossible it seemed, deserved a chance. The harsh reality: innovation without industrial support. The recurring problem wasn't a lack of ideas, but the inability of the industry to sustain them. Many of the most promising projects ended up shelved due to the lack of materials, tools, or supply chains needed for large-scale production. Manufacturing components like gearboxes, special reducers, or sophisticated electronic systems required technical infrastructure that either didn't exist yet or was saturated with other priorities. Moreover, the centrally planned economy imposed strict utility criteria. If a truck could not be mass-produced, its existence had no practical sense. Unlike private companies in the West, which could produce niche vehicles or experiment with limited runs, Soviet factories were forced to focus on scale and standardization. The invisible legacy of experimental trucks. Although many of these models never reached the streets or the fields, their legacy was not in vain. The ideas and technologies developed in them fed other branches of industry. Composite materials ended up being applied in aviation and shipbuilding, electric motors evolved for railway use, and the lessons learned about transmissions and thermodynamics were applied in heavy and military machinery. It also shaped a generation of engineers used to working with extreme limits, scarce resources, and utopian goals. These men and women, trained in the era of impossible trucks, would later be responsible for keeping the transport industry alive during the harshest years of perestroika and the post-Soviet transition. A gallery of mechanical ghosts. Today, some of these vehicles survive in museums or private collections, others are lost forever. But all share one quality: they reflect a historical moment when Soviet technical imagination overflowed without limits. Not always successfully, but always with admirable conviction, the belief that everything was possible with ingenuity, persistence, and a touch of mechanical madness. From the electric Colossus MAZ 525 TTU to the gas turbine Kraz 2E 260E, passing through the fiberglass dump truck ZIL MMZ 555P, each was a risky gamble on building a different future, and although that future never came, their traces remain in yellowed blueprints, in black and white photos, and in the rusting memory of trucks that once dreamed of flying across the earth. If these rare and forgotten Soviet trucks sparked your curiosity for the unusual and the impossible, leave a like, subscribe, and ring the bell. There are still many hidden machines waiting to be uncovered in the archives of time. See you in the next episode, where the history of the motor always has an unexpected twist.